Hello, dear friends. I'm going to introduce myself. I'm Javad Tahantan. I am a freelancer and I work with various geotechnical softwares such as Abacus, Plaxis, and other softwares. And you can contact me with my email and my phone number. In Telegram, you can contact me. Uh, in this video, we are going to model a twin tunnel in a rock mass. Before talking about the model, which you are going to see the final model in the plaxis 3D, we have to define our tunnel shape in a AutoCAD software. So this is something that we are going to model. As you can see, there are two tunnels and there is a surface load on the soil mass, and the soil has been defined here in show material. But about the tunnel, before starting our program, we model the geometry of tunnel in a AutoCAD software. As you can see, this is like a horseshoe. So there is a star in the middle and there is a horseshoe tunnel around this shape. But after you finish your geometry, as far as you want to, for example, import this shape in plaxis, you have to delete extra lines. Like this, you can delete extra lines and make a very simple shape. I do this process before, and you can see number 6 like this. I did not delete the middle lines, horizontal and vertical middle lines, because in the plaxis I want to make some subsequences and use NATM excavation, and I'm going to excavate this tunnel in 4 different stages. So we are going to see the final model. As you see, there is a soil. We can right click and hide the soil, and we can see that there are 2 tunnels. Each of tunnels can be changed in here. Tunnel 1, right click, edit, and here you can see the geometry. Here you can see the subsequences and transiency and sequencing. So before starting our new project, I must tell you that I can give the project to you and you can try and practice on the final project. I should note that this video will be recorded in 4 different parts, and in the first part we are just going to talk about the material definition and geometry importing and these things. So these 2 tabs, soil tabs and structure tabs, are going to discuss in the current video. Okay, we are going to do another project. In the first of the when you open the plaxis 3D, you have to make a title for this. For example, we say exercise. Exercise. I think the spelling is okay right now. Then you can, in the model tab, you can define your surface geometry. In this video, let us to use 16 meters for x maximum x and 0 for x minimum. Also 50 meters for y max and 0 for y mean. The units of length is meter, force is kilonewton, and time is day, which did not use in the current project. We do not use consolidation. If you model consolidation or something like that, you will be need the time unit. So normally we use second or day. These two options are more common. So after you click OK, you will see this first page. You can click on create borehole, and in this part you can you can assign your borehole. But before that, I click on escape and I define my material: soil, material, soil interface, new. So what is the name of my material? Let us use a predefined project, as you can see here. Okay, here in Spanish language and here in English language, we can see that we have a two twin tunnel. Each of them has 100-meter length, and okay, the long side to the short side dimensions must be between 1 to 1.2. So as we see here, we can see dimension here, dimension. Okay, this is 11.17 and this is 11.80. So the ratio of height to the width of the tunnel is equal to 1. As we see here, one of the projects should be 1 and another can be 1.2. So A to B ratio is 1 in the current program. So for the first material, the rocky material, rocky mass parameter, or in Spanish language we say macizo rocoso, we have these options for our material. So as far as we have GSI, MI, and D, we can find that the model behavior is Hooke-Brown. In Moore-Coulomb, we need cohesion, friction, dilation, and elasticity and position. So we change this to Hooke-Brown here. We will define gamma unsat on 20 and saturated density on 20. As we see here in the project, saturated density is 20 kilonewton and unsaturated density is also 20 kilonewton. Although we should consider that saturation will be increase the density of any material. Each type of soils will have more density in saturated position, saturated condition. So maybe it could be 21, but as far as in the current project, the soil is dry, it is dry and there is no water in the soil mass. So the project define these two parameters equal to each other. So with considering this to 20, we are going to mechanical property. Let us use, for example, 100 megapascal or 150 kilonewton for our elasticity. 100 megapascal of elasticity. Poisson could be, for example, 0.3. Uniaxial compressive stress could be, for example, like this. Again 100 megapascal. We can reduce this to, for example, 80. We can observe the different material values and the effects of, for example, elasticity on the result in the next videos. The final video will be discussed about the results and the effect of elasticity and other parameters, which we are going to talk about them in the final video. So MI 25, DIN 25 for this, 0.5 for this, and okay, 0 DSI 45 and 0.5 for this. As far as we define everything, when we click OK, there is nothing here said invalid. For example, if we change it and we delete, for example, GI, when there is no GI, or when you don't define, for example, this parameter, by clicking OK, you see that here write it invalid. So you have to edit it again. But the name is not proper. Let us change the name and write Rocky Mass. Rocky Mass. Okay. Now we have to define a plate for our shotcrete. As far as we know, in this type of modeling, shotcrete will behave as an elastic material. So behavior material type would be elastic, and the density would be, for example, density would be 25 kilonewton. Here there is a little problem with my software that I'm going to solve it right now. Okay, let us continue. I hope the problem has been solved. So here you see that invalid in front of the name of the shotcrete. So we can edit this. We can change the name. Okay, we type shotcrete here. Elastic behavior gamma or density is 25 kilonewton, and the mechanical behavior could be isotropic with the dimension of 0.1 according to this file, and 30 megapascal of Poisson is 25 and elasticity is 25 megapascal. Okay, we click on OK and we finish our material definition. So now we need to define a borehole. As you can see, we can define a borehole, for example, in 0, 0, 0 point. We can add and make a borehole. Top of the borehole is in the surface of the ground, and the level is 0, and the bottom could be, for example, minus 50, and the material would be rocky mass. Okay, so we have this definition. As far as you see, the direction y is just, for example, 50 meters, and in the project we see that it should be 100 meter. So we are going to find project properties, model, and we change this y maximum to 100 and click OK. So this is our mass. Next, we are going to define our tunnels. We can define our first tunnel in this. For example, we click this value to be 0. Okay, and we click on tunnel, create tunnel. in, for example, we can change it in the next steps, but for the first, we have 50 meters depth, and the bottom of the tunnel would be in 30 meters with 50 meters distance from the left boundary. We click here. This page will be opened. So we can go to segment and import our AutoCAD file. Here we click on best 6. You see the geometry has been defined. If one of these lines has not been imported in the file, you can change the mesh point, or you can change the scale. As far as the dimensions has been fixed in the AutoCAD, and there is no problem in the height and width of the tunnel, so we can make it okay. You click import, and so we see the different part has been defined here, and the general project is here. We can although we are talking about these options in other videos in Persian language and in English language, we are talking about the free circular template and other options, but here let us introduce our interaction and our shortcut to the tunnel. So we are going to subsequence. Here we see the all of the subsequences. In the property, we can define our property here, and in the different parts. You can add rock bolts with reinforcement. Here, this option will give you some rock bolts, which is not important for us in the current project. Let us define some extra things. Create plate. So there is a plate around the tunnel which will define our shot grid. And now again here, right click, create a negative interface for our interaction between tunnel and the soil. So these two are negative inside, so we can define, create positive to outside, and delete this, for example, negative ones. Negative, delete, negative, positive, delete, negative, delete. Again here. Oh, I'm sorry. Negative, delete, and positive. Okay, so here we have our interface, and after that we can define our sequences. 1, 2, 3, 4, 5, 6, 7, and 8 would be great. In the first step, or let us introduce another one. Okay, it is not necessary here. This is a little hard to talk about the routines. You can, in the first step, as this video would be a general video, we just talk about the sequences in one step. In step 1, we define the project to let us add 9 to do nothing. The soil would be in this place, and there is no shortcut, there is no interaction. But in the second step, we deactivate this part. After that, in the third step, we deactivate this part. Also, we add our shortcut deactivate our shotcrete and our plate. After that, in the force, we delete these two steps, or you can do this like this to have a better sequence. Okay, nothing in the first. In the second step, deactive, add. In the third step, active, add. In the deactive of the left, add, active, again add, deactivating this part, add, activating this and this, and finally deactivating this and activating these two parts, doing them one by one. So in the final of modeling, we will define different steps in stage construction, and the tunnel will be do these steps one by one. In the first step, there is a soil, and there is no interaction between soil and the soil, and it is very normal. After that, we excavate this part of the tunnel, and the stress will be reintroduced in the soil mass and redistributed in the soil mass. After that, we make a shotcrete here, so there would be an interaction between the shotcrete and the soil, and we continue this. Okay, we will going to click on generate, waiting for a minute to complete the process. And as we see, after finishing this step, we could have a tunnel with the length of 100 meters, which is modeled in the depths of 30 meters. The bottom of the tunnel is in the depths of 30 meters, and top of the tunnel, of course, it is in the depths of 20 meters. But here we just have one tunnel, and there is we need another tunnel around the first one, so we should wait a little more to become sure that the tunnel has been generated. We can also save our tunnel geometry here on general template, or we can for example, excuse me, here on save, and we can save it with the name of horse shape tunnel. And then in the next project, we can easily horseshoe tunnel. I write it wrong. Horseshoe tunnel, which is PTNL file. And in the next project, I can use it very easily. So I click on generate. I think there is another problem with my software, and we wait for this to be solved. So in the I found a problem in the this tutorial and in this video recording. We have a problem, invalid cross section, because cross section is not closed. So there is a problem in for example, importing the geometry. So we have to do this again, and let us delete the whole project and import it again, and delete these two. This is the not defined line. Although we can draw this here very easily, but as far as we want to model this with software, we do this here. Okay, here we can even use this type of tunnel with no horizontal and vertical line, but I don't want this, and I want to do the best as I can. So you see this line is not defined well. We can do this like this and merge point with bigger values. So here maybe the problem has been solved. Okay, sequences, and here, okay, properties, create negative. Okay, here it is. Okay, as far as all the interaction are negative in the right part, we could see that we do this right in this time. Finding these kind of problems during the recording videos will be very great, because we find the experimental solutions to solve the problems. So here very easily we can do this one by one. Here we can active this and deactive this. Okay, let us delete these steps, and now here and here. So add this, deactive, add, okay, active, one by one. Do it one by one. Not use the control on your keyboard. Now we can click on generate and hope that the problem has been solved according to the new change. Okay, there is another problem. It says that no transiency is specified. Okay, transiency, yes. We have to define a transiency for our project, and by using segments, there would be a length of 100 meter of tunnel, and we can define slices to be, for example, by length 2 meters in each length. So 100 meters of tunnel would be excavated in 50 stages, and in each stage 2 meters of tunnel would be excavated, but the 2 meters of this tunnel would be excavated in 4 different parts. Now there is nothing else, and we can generate our tunnel here, and we hope that having no other problem. Okay, the star has been gone, so we are finished. We click on close, and our tunnel is here. So we can go here, copy the tunnel, and make another tunnel just like the first one. But for copying tunnel, we should use this button, creating area tunnel 1. Another tunnel should be copied in the x direction with the space of, for example, 50 meters between the two tunnels. This is the meter as far as we define the meter in our geometry at the first time. Okay, we click OK, and we see there would be a tunnel here. But after that, we see that the space between two tunnels is very little, and it is not good for us. So we see that here is 50 meter, here is the final in 40, here is 25, and here is 30. So we are going to displace this tunnel for 10 meters. We just click on tunnel 2 here, and we just change the x to 40, and click on somewhere else. So the tunnel displaced and becomes 10 meters far than the first one. So we finish our structure and soil tabs, and we are going to mesh the tunnel in the next video. I'm very happy that you see this video. I hope this would be helpful for you. For the beginners and students, you can contact me with email or Telegram with the Iranian number. The two first numbers are 98, the code of Iran, and you can be in touch with me in Telegram and YouTube. I hope this video would be great for you, and we are going to continue more videos in Abacus, Plaxis, and Flag, Itasca Flag 2D and 3D. Have a good day. Goodbye for now.